Hey guys, welcome to the first episode of Ferris Makes Demos, not Ferris Makes Emulators. This is, I hope, the first in a great many streaming episodes that I do that are focused on demo scene, which, for those of you that know me, especially that knew me before doing the emulator stuff, know that that is a big thing that I do in my free time. Go to a lot of demo parties, make a lot of demos. It's pretty fun. So I thought that I should do... So first of all, a bunch of people who are regulars on the stream, I basically started contributing to my Patreon as well. I set a goal on the Patreon that if we met $50 a month, that I would start doing 2 streams a week, and that happened really, really fast. So yeah, that's pretty cool. And I decided the second stream would be demo scene related. So that's what this basically is. By the way, hey guys in the stream or in the chat. By the way, if I know a bunch of people said hi, but I didn't. I keep refreshing my page like before I go live, so if I missed your message, I'm sorry. But John Hunter, Jura, Creekpot, Daniel Collin, Soda Design, FPGA, Nugga, Lord, Jonel, nice to see you guys again. Now, I hadn't really planned that much in terms of like what I wanted to go over on these streams. I wanted to be fairly laid back, and eventually, after revision this year, I want to do a couple streams where we kind of go over the demo that we're working on right now in the group Logicoma. And Sakes, how's it going? And yeah, like I just want to go over, like do postmortems of demos in kind of more of a live format rather than a write-up format, just because I think that'll be a little more fun. You get to actually see me go through stuff. These will... these should be recorded. I forgot to press the record button, but I'll get it back from Twitch later. So these will be recorded. They will be up on YouTube. But I hope I can do kind of like a behind the scenes things, or like a behind the scenes kind of thing after demos are released, and then also eventually transition to sort of like, this is just going to be an hour or two every weekend where I just sit down and start making some demo scene stuff. So I hope we get to that point. W23, nice to see you. Base Effect, Hardy, how's it going? And Ernest, cool. Good to see a bunch of people here. This is really nice. So I hadn't planned that much about what I wanted to go over, except that I wanted to go over our 64K synth today. Now, for those of you who haven't seen that much of my demo scene stuff, I do want to just watch a couple of the demos that have been done with this synth, and also go over a bit about this track, which is one of our executable music tracks that was done with me and Hoffman. And I wanted to use this as kind of an example to show kind of how the synth works and how we work with it and how it's been designed. If you've seen, I gave a talk about this at the Gathering a few years ago, and a lot of you have probably already seen that talk. This is going to go over a lot of the same stuff, but with newer material, basically. Won't be showing any of the new tech that we're working on for the revision demo, but you can kind of see how modular this is and how that will work. You can kind of imagine it, and then we'll go over some of that if any of it makes it in the intro by then later. So yeah, that's where I'm at. I thought first we would watch one of our more recent productions, and I'm just going to actually run this live from the executable. I want to go over... yeah, Studio C doesn't seem impressed. Oh, that's funny. I want to go over our most recent publicly released intro, which is Elysian. I just want to go ahead and watch that really quick. I also want to watch something called Migraine, which is something that me and Hoffman and Wobble did in 5 hours for another party that didn't end up getting publicly released, but I want to watch it on the stream because it's cool. And it was cool that we made it so quickly. And eventually that's the kind of stuff I want to stream as well, when we start sort of getting into this. Excuse me. I'm a bit tired because I ended up rearranging my whole apartment today. Just kind of a dumb idea before the first time I did this stream, but I figured I want this to be fairly casual. So if I'm a little more laid back, it'd be okay anyway. Ignore the mess behind me. There's still some stuff left to do, but no worries. Let me just pull up this demo. And I might have to adjust the volume, so let me know if that is not good. Final, this one. Okay, so we're in the executable. Get this little dialogue. Doesn't have enough resolutions in here, but that's fine. We're just going to do a full screen, and we'll just deal with this title bar as well. This is available on YouTube and Poet and everything, so not going to do too much about that. And I'll probably continue to talk a bit over this. This track was done solely by Hoffman. No sound. Should be getting the system audio. I'm seeing it here, at least. Yeah, I'll turn it up. Is that a good volume? Cool. So this is running real time on my PC. And again, this track was done by Hoffman and not Wobble and I. Usually a couple of us will collaborate. This track is the biggest track that's been done with the synth. This intro is like 56K, and the music and the synth, like by themselves, were like 30. TJ, how's it going? Thanks, guys. I will attempt to do that hardcore head at the end of the demo really quick. I'll attempt to do that. But real-time digital art is pretty good if you want like a 3-word definition. It's funny too, because like even just showing this on the stream, I still get the same kind of nervousness that like you get when it's shown on the big screen. Daniel Collin, what do you say to FPGA Nugget's suggestion? I don't think he realizes that you're Emoon. But I agree, you guys should do that. So that's most of it. Speaking of postmortems, by the way, FPGA Nugget, the Spaceballs guys put out a demo called Mocked, which is pretty cool. And they just did a write-up of that. Let me link it in the chat, because it was really interesting. I sounded sarcastic, but that's because I'm multitasking. It actually was really interesting. Because it was one of those demos that like looks really sick for an Amiga 500. And I work with Slummy, and so like I asked him basically how it worked, and he kind of mentioned a little bit. But I kind of didn't get a lot of the context until I read this a few times. And I love it because it's conceptually so simple, and it's all the technical and artistic details that make it really cool. Anyway, that's about their demo. Our demo is probably not as... Well, I guess it'd be a different kind of hardcore technically. So... Studio C, that some new trick. I think I was talking about that. I think it was the same link. But yes, to give you guys a little more context for those of you who aren't that familiar with the demo scene, it's basically we write programs that make real-time digital art happen on your computer. I don't really know how else to put it in less words, but the idea is that like you can imagine it as similar tech to a cutscene in a game, but we do it just as sort of artistic expression. And oftentimes, just because of something to do with how limits will sort of encourage creativity, a lot of the times these demos are size limited or platform limited. Like there's often demos on old school platforms, like Amiga is a really popular one, C64. I've done a couple on Super Nintendo and Game Boy. And then this demo in particular was 56 kilobytes in size. So that's one executable with no external media, and it generates everything. Hybrid Idolin, how's it going? Thanks for the follow. But yeah, so it's 56 kilobytes and it's one executable, and then it will basically do that, what you just saw on the screen and heard, and then we'll close. And that's it. And it's just fun to make. So that's pretty cool. Real-time music video is I think, pretty accurate, Dana Colin. Although that really depends on the group, I think. This one I would definitely say is kind of a real-time music video, because at least a lot of the stuff that I've done tends to be focused around the music, and this was definitely no exception. It's funny because Logicoma is like 4 people right now, and 3 out of the 4 of us are musicians. This one renders during playback. It has like a 1 second buffer just for extra headroom, but this one actually does it live. Fmaster, do you need to know assembler for those platforms like Game Boy? No. I think you can do it in C. Although, if you're going to learn assembler, that's a pretty good one to learn because it's really comfortable. But yeah, back to synth stuff. So that was Elysian. That won the demo, or the 64K intro competition at Tursock this last year in October. Hardcore Head 87, how random was everything you saw and heard? Nothing is random. It's like all the camera pass and all the music and everything. Like nothing's random. So we don't really take advantage of the real-time aspect in that sense to make it like random or different every time. Some demos do. It's not like part of the limits. It's just that we don't in particular. Like the Logicoma project for me is kind of trying to do motion graphics like stuff in the demo scene format. So everything ends up being pre-calculated, and that's pretty not pre-calculated, but like predetermined what it's going to do, and that's pretty common. I would say that's a lot more common than randomized stuff every time. Studio C, is there any restriction on loading time nowadays, or you can use as much pre-computations as you want? Some parties recently have started to add pre-calc limits. It's usually like 5 minutes, which is pretty longer than a lot of demos. In fact, the first Logicoma prod was a 64K that actually pre-calced the whole song the first time because I had some denormal issues that I didn't fix before the deadline. So that's fun. Won't be watching that right now. So that was one of the things I wanted to watch. Another one is this one called Migraine. So design LUT used for this. I don't know what you mean by lookup table in this case. Thanks, Sakes. Yeah, I think demo scene is a pretty good way to combine music and programming. And I hope you'll like some of the synth tech as well. Give you a better idea of how this works. So this next thing I'm going to show is, this is a 44 kilobyte intro. It would be in the same category as 64K, but this one happens to be 44 kilobytes. This is one that we made in about 5 hours for a party that I still don't know if I can reveal the details for because of some affiliations with a corporation that ended up, or corporation may not be the right word. Anyway, like we may actually not be able to release this properly, which is really kind of a bummer, but I really want to show it because I thought it was a good, really different example for the synth. And it's also, yeah, it's basically the same tech we used for Elysian, but done in a much shorter time period. One Friday night. I'll be a bit quieter for this one. So that one was aptly named Migraine. We wanted to see what we could come up with in a really short amount of time, and we think our tools are working, so that's pretty cool. That was done in mid-November, I think. It's done a few months ago. But yeah, I think that's pretty cool. The last thing I wanted to do is play this song here. So usually, when we talk about like 64K intros, for example, or demos in general, like they're kind of a few different main pillars. There's usually like the code that makes the effects work. There's like the graphics, there's all the pixel art and everything, and then there's the music. And especially in these kind of intros, you don't see that much like pixel art and that stuff. So you can kind of remove that, at least from the way our group does it. We don't really have dedicated graphics people. I guess you could say that like the content of the intro is the graphic stuff, but it's the same. It's us doing it, the same people making the tools. So it's kind of, I like to think of it as sort of those two pillars, at least in our group. So sort of the visuals and the music. And I want to talk about the music in particular because we've been using these same tools for almost 5 years now, actually. Not necessarily Logicoma, because Logicoma has only existed for like a year and a half or something. But also used it in a couple Youth Uprising things. And Hoffman and I have done a lot of collaborations on executable music entries over the last couple of years. And this is what one of those things are. So executable music is a format that's... So the demo scene has like a lot of competitions when you go to these demo scene demo parties, which are like gatherings for people who do demos. There's a ton of these a year, and a lot of them have different kinds of competitions. So you'll have a demo competition, which is like the stuff I've been showing here, but it's not size limited. You'll have the intro competitions, which are various size limits on those. Both of these that I've just shown would be in a 64K limit. Bass effect, how big in bytes is the music? Yeah, I'll get to that for a sec. I'll get to that in a sec. So, what was I saying? Yes, and then you'll have like graphics competitions and different kinds of music competitions. One of the kinds of music competitions that's around that isn't at some parties, but not every party, is an executable music competition. And oftentimes these are, okay, you write a program, and that program has a soft synth in it, and it will play music, basically it. And if you look at it in the context of like these intros, it's basically if you take away all the visuals, then you have executable music. And so when you're developing tech, like I started the Synth about 5 years ago and started working on the tech for the purpose of doing 64K intros. But then executable music competitions are a really good way to like test the tech and start using it kind of on its own and in isolation and refine that tech before you ever have to actually put visuals to it. Because, making the audio tooling is a lot of work, making the visual tooling is a lot of work. So it's kind of cool if you can separate the processes a little bit. F-Master, I'll pay you $1,000 per hour to learn how to do this. Yeah, let's talk about that. Bass effect, how big is in bytes is the music? It really depends. Is my best answer. So in different executable music competitions in particular, like so in 64K, it really doesn't matter how big it is as long as your whole thing is less than 64K. And usually the tracks that we've done with my synth have been around like 22 kilobytes. Which is decent. A lot of groups will limit that to 16 for the music, but I don't really mind going a bit above that, especially at the kind of fidelity that things have to be at now. Now, a lot of the intros are less about how much content can you actually cram in there. They're more about how high quality is the content that you have in there. So we're not seeing a lot of like mesh data. We're not seeing a lot of like it's not the amount of content that's really impressive anymore. It's the quality of the content. So adjusting those limits a little bit, I think is fair. However, in executable music competitions, there's usually two different limits. So you usually have, like some parties like to do a 16 kilobyte limit on that competition, and other parties like to do a 32 kilobyte limit. Now, since most of the tracks in this synth are around 20K, that's obviously too big for the 16K limit, so haven't really entered any of those. And I don't think we're going to try because, again, this synth was really made for 64Ks, and it's cool that we can use it for other stuff. But yeah. Yoam, how's it going? So the 32K ones are the ones that we've actually, entered in quite a bit. And this is one of those. This was from Tursock 2015. So this is in Denmark in October of that year. I actually wasn't there at the time, but me and Hoffman passed this track back and forth, listened, and entered it into the competition. I believe we won that year. We might have gotten second, though. I can't remember. But I'll just start playing that. I think this was about 27 kilobytes when it was all over. I mean, because if your limit's 32, you might as well put as much stuff as you can fit in there. So. No worries, Yooms. Good to see you, man. F-Master, I do have a Patreon, by the way. Just saying. Glad you're enjoying it, though. Yeah, I hope to lift the veil a bit. Feels. Should be fun. The drums are a mix of synthesis and sample data. Four Ks are pretty similar to 64Ks, but obviously more limits. I mean, you'll generally have a soft synth and everything. Yeah, Sakes, you should try this stuff. F-Master, I will keep making this content. I'll answer questions in a sec. Cool, F-Master. Really good to hear. Yeah, demo scene stuff is rad. Greekpot, I still find it so fascinating and awesome that the demo intro stuff became its own scene. I totally agree. For those of you that may not be familiar with what he's talking about there, he's basically mentioning that back in like the 80s, there were these like you would get games and you get cracked versions of the games that would have like cheats and all that kind of stuff. And then the groups that would crack these games in the boot sectors of the games would inject a little program that before the game started would show like a logo of the cracking group and the names of all of them and stuff, and giving the finger to all the other groups and all that stuff. I'm really oversimplifying this, by the way, but just kind of want to go into that a little bit. And that ended up, like, the effects that they were doing in those little intros ended up, like, people were pushing the limits and pushing the limits. And the whole demo scene basically branched out of that. Like, there was still the cracking scene that kept cracking games. And even now, you'll hear a lot of like chiptune stuff, or see these kind of old Amiga-ish effects in these little crack intros in cracked games now. And that totally goes back to those roots. But then the demo scene, and especially the intros, really branched off in sort of the other direction, where we just kind of want to push the artistic limits. And the name intro, that's why I say especially intros, because the name intro actually comes from that root, where it was an intro to a cracked game. And that's also like that's why the size limited ones are called intros. So that's kind of cool. Sakes, the audio that we hear now is a fact that you programmed yourself? Yes. Or in fact, a synth you programmed yourself? Yes. That's what this is, and that's what I hope to go over a little bit today. Playing in Ableton Live, because that's the content creation tool that I chose to support here. Hey, Delta, how's it going? So yeah, it's pretty cool. So this synth is called WaveSabre, and it covers basically the soft synth and then a bunch of conversion tools and the replayer code. Currently, it's not public. Basically, a lot of the tools I'll be showing are not public right now. I do plan on open sourcing a lot of this stuff, especially the synth, because I know that there are other people who want to use this. But yeah, I don't really have any date for that or any concrete plans for that. It's just we'll do that eventually. So I guess I should get into some of the technicals. I'll get to your guys' questions, but I think it'll be better if I get to those in some kind of organized order. So first of all, the synth is made in C++. I actually have some old slides from a talk I gave about this a few years ago, and so I can just pull some of those up and kind of walk through them a little bit. The synth is done in C++. And this is kind of the sort of software stack that I did, or that the synth uses. Sorry, I'm a little scatterbrained. But at the bottom, you have what we call WaveSabre Core, and that is sort of a library that just contains sort of, right? So it has envelopes, it has oscillators, and it has a bunch of devices, which are like the various synths and filters and all that stuff that use those lower level components. And that's basically all it has. It just has a bunch of these building blocks. Then we have sort of two sort of pillars that we have. The one on the left here has to do with basically playing sound in an executable, and the right here has to do with sort of orchestrating those bits into a hearable song. So you can think of this as like the replayer and all that stuff. You can think of this stuff as the tooling that we actually use to make the music. So at the top, you'll see like this is the intro or the executable replayer and the executable music. And then we have this WaveSabre player lib that just kind of is able to take like a serialized song and then sort of unpack it into a little graph of these audio devices and then start playing it. So like the idea is that this top level stuff is the only stuff that changes between every executable music entry we have. We basically just take a binary blob that comes from the tooling and attach a little, like some text to it in the console and then pack it up, and everything else doesn't change. On the right, we have WaveSabre VST lib, which is this sort of library that binds all these little devices to a particular VST libraries. And then at the top level, we have these VST plugins. There's a little more to it than this, just because, I might as well just open up Visual Studio here because I do have it open. My font is tiny. Sorry, we're just going to have to live with that because I don't want to mess with my config here too much. But if we look at some of this stuff, here's the core that I was talking about. And if we look at some of the stuff that's in here, so this is, I will answer this question. Is that Tanky Online Sport? I'm not sure how to say that name. Is this a regular VSTI that should work with any host? No. That's, let me actually show you in Ableton, and I can kind of explain that. So the thing is that we want to work in Ableton Live, and because that's a DAW that I'm particularly comfortable with, and it turns out Hoffman is as well. Really, I made this for me to use it initially, and then Hoffman was also able to use it with some great success, I might add. This song, by the way, was made by both of us, passing it back and forth. But yeah, so the idea is that I'm going to kind of skip over some of the stuff that's specific to Ableton because that's not terribly important, and try to focus on the stuff that's particular to the synth. So each one of these things here, these are tracks. They're all MIDI tracks, so they will have MIDI clips on the left here. So like I can sort of expand these, and you'll see these clips on the left, and we can go into those, and you just see some MIDI data. Not particularly much stuff. And then they have things like volume. They have which track they send to, that kind of stuff. And that's basically at the lowest level. Like that's kind of how the project is laid out. And then on each of these tracks, in order to turn that MIDI into actual music, we have a bunch of devices. So for example, I can look at this this chord stab track up here. We have this MIDI up here. So let me just sort of solo this. So that's this kind of sound. So you can see how the MIDI would represent the notes to actually play that. And then down here at the bottom, we have the different devices that are used to actually make the sound. So the farthest one on the left is a synth device. If I pull that up, we can see one of the first actual WaveSabre specific UIs in this whole kit. So this is a synth called Slaughter. Slaughter is a subtractive synth. Basically has a few different oscillators with some very basic waveforms. Basically either sawtooth or square wave or something in between. We have a crossfader between those because we use these. This kind of synthesis allows us to do that. And also has a noise generator, has some filter stuff, has a filter envelope, has a volume envelope, has a pitch envelope, and then it has a bunch of voicing parameters so that it can actually sound thick and nice. So I can actually mute these. We can kind of go through, I guess, some effect chain here. I'll be bouncing back and forth probably a lot between talking about different parts of the synth and different things, but just want to keep it casual. So this is the original sound. Then we have Scissor. Scissor is a distortion unit, and basically at this type, it's basically a hard clipper. So it's harsher. Then we have Crusher, which is a bit crush. In this case, it's being used very little, actually, if at all. Yeah, it's pretty light, but just to make it a little crunchier, I guess. Then we have Leveler, and Leveler is a 3-band EQ with a low pass and a high pass. Not much there. Also, it looks like. Then we have Chamber, which is a reverb. And I guess that does a lot of the heavy lifting for this sound. And then last in this chain, we have Echo, which is a delay unit, delay and echo unit. So it has like a left and right delay line that sort of feed back into each other. And then we'll also cross into each other's fields. There's also a low pass and high pass in that feedback matrix, which makes it really controllable. So just more and more space. Now, the reason I kind of wanted to show this before getting into like saying, is this a VST? This is a collection of VSTs is kind of the point here. And the idea is that you use Ableton to compose a track kind of like you would any other song in Ableton, but you only use these VSTs. And then there's a couple limitations on things you can't automate. Like you can't automate track volumes. You have to automate only parameters that are on these VSTs. These GUIs are just super, super basic. Like this is... I can show you the code to make these and stuff, and it's, yeah, really, really basic. In fact, I think this knob graphic was ripped from FM8 at one point. Now we make it ourselves, but the idea is just that like all the parameters are float parameters from like 0 to 1, so we just have knobs for everything, and they're just laid out in some kind of way that's sort of nice. The the reason behind that is we want to keep the GUIs as simple as possible, because the idea behind the synth is that the devices themselves are what we want to keep evolving over time. Like the synth core is basically about, okay, we can put a bunch of tracks together and pump audio data through them, no worries. But then what the devices do and how they interact is kind of the interesting stuff. And so we want to be able to iterate on these really quickly and just pump them out if we want to change stuff. F Master, no man, thanks man. I really appreciate hearing that. So like all the songs are basically made like this. Like we just open up Ableton one day and start laying out stuff like this. There's again like these synth devices, and there's also these devices that modify the sound. I guess we can pick a kind of crazier sound to show you kind of how crazy these effect chains get. And the reason why I want to show that is because like we're not limited by the tool that much. Like this is kind of a nuts effect chain. I don't know what all the stuff in here does anymore. But this is like in this sort of drop part. And this is I think it just goes, if I remember. Yeah. Just some really grindy thing. It's part of a layer here that make this really aggressive sound. But a lot of these, I'm pretty sure, are just going to be EQs and distortions. Yeah. Yeah, that's basically what it is. We have this FM synth here called Falcon, which is basically this 2-operator FM synthesis plugin. I mean, it's really basic FM stuff. I guess I don't think I have FM8 installed on this machine, but I basically took FM8, which is a Native Instruments FM synth, and I made this really basic operator graph, and then I just sat there and played with it and tweaked the output and compared to my own stuff. And I found all the parameters in their synthesis and like all the constants in their FM equation. So this literally sounds exactly like this particular operator configuration in FM8. And really that's mostly just because like, oh, they already have all these pre-tweaked values that sound good, so let's just steal those. And that works pretty good. Bass Effect, how do you save load patches? You don't. I don't have patch support in here. CreekPot reminds me of the old analog modular synths that were just walls of knobs. Yeah, it's pretty much it. I mean, it's like the simplest interface you can have. Studio here, you're planning on making more devices to the set. So we've already added a couple features to some of these devices over the years, and Hoffman's working on a couple new devices. So yes, the idea is that's always changing. And when I open source this, I want to encourage people to make their own. Like the ones we have are ones that fit the kind of music I make and the kind of tools that I'm used to working with. But they really could be like basically anything. So that's sort of the idea. But yeah, again, remember that these tools are made for doing 64K. So if there's some feature like patches that are missing, it's just because, okay, I didn't need patches. So like we just don't have it. Like these are not meant to be the most comfortable thing ever. These are meant to make music for 64Ks. So there's a ton of like, that's also why the interfaces are so basic. And I believe very strongly that that's the right way to do these things. Anyway, a sound like this, going through each bit probably isn't like that insightful, just because it's going to be a lot of like the way we would have made these is we would have just slapped on effects and just tweaked knobs until it sounded good. And here you can just kind of see it's a pattern of like, okay, here's the FM synth, and then there's an EQ, and then a distortion, and then an EQ and a distortion. And if I just sit here and like start muting EQs, you can kind of see, oh, that takes out this part of the sound or whatever. But I mean, it's always just like whatever we feel like doing. But the whole song is basically that. Like we have that, and then we have, so it's basically MIDI going through these devices on a bunch of tracks. A couple tracks will also just take in a bunch of other tracks and then do some additional filtering on them. Like we have some sidechain compression and stuff like that. The master chain, we do some extra clipping, things like that. You'll see a bunch of disabled things in here as well. That's plugins that I don't have installed anymore. Not too important. Base effect about patches, you actually could do, one of the things you can do in Ableton is like if you navigate in the browser to one of your other songs, you can just grab tracks. I end up doing that instead of taking patches. I mean, could add patch support. When we open source that, that'd be a cool thing to make a pull request for, but just never something I needed. Anyway, so yeah, so it's basically just a bunch of MIDI going through a bunch of devices on a bunch of tracks that then get mixed together. And then we also have automation. Let me just see if I can find one. Like one of the risers will have this. I really like making these rise sounds. So yeah, so for example, these, this is like a sound in the background. It's literally just meant to get you hyped up. That's it. Rower, thanks for the follow. So you can see here that this is automation. So this is literally just changing one of the synth parameters over time. In particular, I have a parameter on all the synths called rise, and that literally makes it go up 2 octaves or something. In this case, only 1 octave because it goes half the range here. Base effect, no, you do have patch support if the VSTs have patch support. That's just, I'm lazy and I just do that instead of adding patch support in the synth. It's not that Ableton doesn't support that, it's just that I haven't made those in the synths. So the whole thing is made that way. I think the one other thing is that there are samples in here. In particular, the kick and the snare are often samples. And the sampler device is going to be disappointing. It's a button. And this will literally load a sample. It just gives you a thing. And that's it. And the sample also has to be a particular format. Has to be 44.1 kilohertz, has to be mono, has to be signed 16-bit PCE. Really particular about the format, but then it will just work. It runs it through a GSM codec that's system standard on basically all Windows since XP at least, and then the compressed version of that, the output from the codec, is stored in the intro along with the rest of the song data. It's just as part of the patch for this particular device, and then that gets decompressed before the intro starts playing back into PCM, and then just gets mixed like everything else. So FPGA Nougat. So that's sort of the next part. The first part is that we just sit here, and the whole idea is that we just make the song with these plugins, and that's it, right? So we don't want to think too much about the process there. The idea is this, like, here's your sandbox, do whatever you want. After that, we have an Ableton project, and this Ableton project has all of the information for all these tracks. It has all the information for all these MIDI clips, and it has all the information for all these device chains and also their patch data. Now, what's cool about that is that you can, if you understand Ableton's project format, you can just rip all that data out and then put it in some kind of other form that then the executable will then sort of unpack and then start playing. And so so that's what we do, is we basically just parse the project file. Now, it's not an open format, but if you rename the .als file to, or you don't have to rename it, it's basically gzipped XML. So if you un-gzip it, then you get XML. And then from there, it's easy enough to figure out the stuff we need. So we didn't reverse engineer a lot of Ableton. Like, I didn't dig into any of Ableton's code. I just looked at the project files, and it was just this process of like, okay, let's make an empty project. What does that look like in the XML? Let's add a track. What does that look like in the XML? And like just over and over again, and basically got enough of the format to be useful. So there's a tool. In this case, it's called Convert the Fuck, which is the front end to this WaveSabre convert library that will parse a live project coming in, do some transforms on it, very simple stuff, and then dump this sort of binary blob. And then that binary blob goes in the intro, and then the replayer will deserialize that blob into a graph of devices, and then the replayer will start pumping audio data through there. And that's like the whole kind of thing. I think I had a somewhat graphic explanation. Not graphic in the sense of awful. Oh, check this out. I said C# is the best language in the world. This is from 2013. I was 20. Maybe 21. Anyway. Yeah. So like, we used to also support Reaper. Don't have that anymore. Maybe I don't have that. I thought I had. I guess this works, right? So we produce everything in Ableton. That gets converted to, it used to be a header file. Now I don't think it is. Now I think it's a binary blob to support the Rust stuff. And then, yeah, at runtime, it just gets, unpacked. Yeah, the names like convert the fuck are totally just like, I did not make this tool to make it public. Yeah. Complete. Cool. So, I mean, that's, the rest of this are details, and I guess I could just kind of show you guys around a bit, because why not? So, like, you can basically think of the life of a song as, like, we make it here, and then, so each of these front ends here, each of these little devices is a VST plugin, and I can show you here. We have a bunch of these VST plugins here that each are their own separate little C++ project, and we use Premake to actually generate these now. Didn't used to, but we do now. And yeah, these are literally just a VST front end that maps some parameters and does a little bit of generating the user interface stuff. It's like this is how we make the UIs. Let me zoom in a little bit here. I can go into the actual synth code, definitely. In fact, I was hoping with this stream that I would just kind of come unprepared and people would ask questions. So no worries, we can do that. Oh, so I just kind of wanted to show like the VSTs. This is like all that's in one of these VST projects. This is a Crusher, which is the Bit Crush. And literally we have the Crusher VST file here, which is literally just creating a where is it? New Crusher here. This is the actual audio device object, and then wraps it in the VST layer and also makes an editor for it. And the editor is literally just creating some knobs and spacers. And then the larger ones, the larger editors have knob spacers and rows. Like it's the simplest thing. Yeah, this is just a VST SDK and VST GUI. In fact, this was the VST2 SDK, and we still just use that because we do. Don't need to be that fancy. Knobs and spacers. That's all we need. So those are the VST projects, and those, like I said, just wrap some audio device. And that audio device is in the core. So like these getting a bit lost what to explain next, but I'll just keep going. So these use something called the VST library, which has class definitions for like this VST editor class, for example, or the VST plug as well. And these literally are just meant to be these containers for these WaveSabre devices, and they're basically just get input from whatever the VST host is and just route it to the synth and vice versa. And so those abstractions are in this WaveSabre VST lib, which uses the VST SDK to just expose those very basic classes. Super basic. I think the only other thing it has is it has some resources for like the knob images and stuff. And the idea again there is that each VST project itself is actually super tiny. It basically just links that library and builds a DLL. And then The actual devices themselves are in the WaveSabre core here. Base Effect, thanks for the follow. I just keep talking, eventually say something relevant. Exactly, John Hunter. Complete, I'm not sure what you're talking about. Are you talking about the Welcome to Space World thing? It'd be funny to have that in a demo. So in WaveSabre core, we have a bunch of stuff. We have like low-level building blocks. Like I have an envelope class. I guess looking at the headers is a little more useful here to see the interface. We can like trigger it, or you can turn it off and get its value and then tell it to tick. Yep. We have a bunch of helpers, which are going to give you things like fixing denormals, clamping values, all that stuff. There's a delay buffer, which is pretty useful, which literally just delays with a certain length, fixed length. We have different kinds of filters. There's biquad here. There's state variable filter, which is even simpler. All these sort of building blocks. And then we have the devices, and the devices are going to put those together into stuff that's useful. And these devices, again, are the things that are actually wrapped in the VSTs and also in the replayer. So if I look at the device class, it's sort of the base class for all these. We have run, which will give you the song position as a double. It'll give you some input buffers and some outputs, and it'll tell you how many samples to basically populate those with. This is like the same interface that you'd get if you implement a VST plugin. It's just it's abstracted away because in some cases this is called from like this is owned by a VST plugin. In other cases, it's owned by the replayer. So this code will work in both scenarios. Elavid, is that how you say that? Is it straightforward to connect the C++ plugin to Ableton? Yeah, just by wrapping it in the VST. So that was also something I forgot to mention earlier. Someone asked if these were cross-platform VSTs. They're not cross-platform just because at least the sampler unit uses some Windows specific code. None of the other ones do, but we just kept it Windows only anyway, since that's what most of us in our group are on. But I mean, it would be possible to make all the other ones cross-platform or just not build that device. But yeah, the whole thing is it's a VST. So Ableton just sees VSTs. And when we parse the Ableton project to get all the data out of those, we like look at the patch data, which is just like some binary blob, because like when you implement a VST and the song needs to like save all your data, like when you save the project, it goes to all the plugins and say, hey, give me some chunk of data to put in the save file. And it'll just give you some chunk. And then when the song is loaded again in the DAW, it sends the chunk back to the device. And we literally just pull those chunks out and then we give them to the same devices later in the replayer. So it's the same thing. And it's basically usually just a big block of float data. So it's pretty straightforward. You could use something else, but so the reason why this is locked to live currently is that's the only thing that we have a converter for, because you need to be able to get all of this routing information, all the MIDI information out of the project in order to properly build the device graph in the intro. And in this case, yeah, we just know how to parse this stuff. Renoise is also really popular in the demo scene for the same reason. Well, also because it's a tracker, but I know of a couple other synths that use Renoise. Conspiracy Synth uses Buzz. Yeah, sorry about that, guys. Don't know what happened, but stream we went down for a second. Anyway, yeah, so like these VSTs, I mean, other than the fact that they're also 32-bit only for reasons, they should work in other DAWs, but you would need to implement some way of getting all that other information that's not just part of the patch data out of the project. One of you guys asked, sorry, I missed who it was. Asked if like virtual will add a lot of overhead. Not really. Not enough for us to care about here. Also, the synth generally is not that speed optimized, but it totally works. But the point is, again, the device just has this really simple interface, and anything that implements this interface can be part of the device graph. So, for example, we can look at a simpler device, like one of the, I guess, the hard clipper is one of the simpler ones. Actually, maybe the bit crusher is probably the simplest one. So this is the bit crusher device that exists both as a VST in Ableton, but also as part of the device graph in the music. And it has this run and get param and set param thing. If we look at the other file, yeah, it just has some things for its parameters, whether or not it's crushing vertically or horizontally, and then like a dry wet. And then we have a couple other things for the left and rights. Yeah, phase and hold to actually do the bit crush. Run will actually do the bit crush based on these parameters, and then set param and get param will just set and get these parameters. Like it's really basic at the most basic level. We also have synth devices, which is another abstraction. This is a thing that is a device, but can also like is meant to play notes and have voices. So it will kind of handle all those things for you. So you, instead of overriding, like you basically inherit from this class to just tell it what kind of voices you have. And then the rest of the work is actually overriding stuff in the particular voices. So you have the same kind of multiple voicing thing for like every synth device. But then we're able to, customize the voices for each kind of synth. And so at that level, like this is all just very basic audio processing stuff. If we look at the player library, there's something called Song Renderer. In Song Renderer, what it will do is basically it takes in a song, which has basically a binary blob, and then it will just start like decoding this. Like it'll get the BPM, the sample rate, length, all that stuff, figure out all the tracks, and then that's basically it. And then it's able to render all of its stuff. The track has most of the rest of the sort of deserialization there. I guess I should show you though, because this is kind of like the structure isn't very defined somewhere in this side of things. WaveSabre Convert actually covers that stuff. So there's, let me just look at the main here, see if I can even remember this. Okay, so there's a project converter, which will, this is all in C#. This is the thing, this is just like a command line utility that basically, so that's what I'm getting into. So it's not like JSON or anything because it needs to be just super small. So it ends up being a packed binary format. But we do have a data structure that describes what that is before it gets packed. So this is the tool this is the command line tool that will, thanks for the follow, Hardy. Oh, hey, Ratchet. Yeah, so this is the tool that will look at the Ableton file and then produce the packed binary that will go in the intro. Lizard, no worries. Yeah, V2M, that's V2. Yeah, V2 is pretty cool. V2 crashed on me a bunch of times when I tried to use it, but it was really nice. I mean, I always just wanted to do my own synth anyway. Like even my earlier 4Ks were all done using a custom synth. So I always wanted to do that. Finally started with this one like 5 years ago. Anyway, so this tool takes an input file name, basically grabs that, and then parses the live project and then parses that. Okay, that's enough of a memory refresher. So here we have the song, right? So song here, which is this structure, this basically describes the actual format that we need to, like if we can get something into this data structure with a couple additional things that should really be documented, then this can be serialized and then the replayer will understand it, right? So the whole thing is that we need to get to this description of what a song looks like. We do that by going through a different structure, which in this case is a live project. So this is like my interpretation of a live project. So we take like the XML from the live project and just pull it out as is into this structure. So this structure is sort of organized how the live project format would have organized things. And you can see we have devices here, we have notes, we have key tracks, which is something in there, MIDI clip track, return tracks, master tracks, all that kind of stuff. And then there's a live converter, which will convert the live project structure into the song structure. It does a lot of stuff like delta encoding notes, things like that to make it compress really well. And And then eventually we get the song, and then we have a serializer, which will take the song and just make a binary version of it, basically. And then that binary version is deserialized in this code here, down in the song renderer in C++. And then we go. So at the very top level, we have something like player test, which this is like a minimal executable that will still replay something or generate a wave. And this literally just uses the direct sound player and wave writer from the player lib, which those are the things that use this song renderer internally. So we have the song renderer, which will, again, unpack all this song data and start playing it, start generating audio. But like that doesn't send audio to your speakers. That just gives you an interface that you can pull audio samples out of, basically. That's used by either the wave writer, which is just the simplest possible thing that will dump a wave file on your machine, and then the direct sound player, which this is the thing that will actually, play sound. And it literally just pulls, like it tells a song renderer to render samples into these buffers, but then other than that, it's just playing. Let's just seriously, yeah. So theoretically, a project can actually be coded as a header file and then compiled together. Yeah, that's the idea. And that's part of the process to actually embed that in the executable. Yeah, there's some hard-coded sample rates and stuff in there. So, I mean, that's kind of it, I guess. Base Effect, I have given out the plugins themselves to people that are interested in making music for this stuff. It's usually if like I don't mind spreading those out too much because it's gonna take very significant effort to actually get the song to replay out of that, or you go through me. So it's kind of like a quality control mechanism almost. But right now I'm not interested in giving it to any new people just because we have a big project coming up. So I don't really want to take on any new people right now. Yes, we will be at revision. Logicoma will be doing a 64K at revision. So that's the big project. Eventually, though, I want to release, or I should say we, because Hoffman's working on this now as well. We want to release the synth open source as well. We want to release the synth open source. We want to release all the song files that we've done for all like the executable musics. That kind of stuff. We might do a music disc for fun. Something like that. Who knows? But that will definitely not happen before revision. Because I won't. So I guess you can kind of see how like the different bits are built up. Maybe I should sort of dig into some of the kinds of synthesis we have. So one of my favorite devices in here, I mentioned that we have an FM synth called Falcon. Basically, all the names in this are meant to like sound like a cheesy 80s cop show. Like these would be nicknames of people that are in like a precinct. I don't know. Kind of what I was thinking when I came up with the name WaveSabre. Like in line with like Falcon Crest and all those just cheesy 80s names. Driven, how's it going? So for example, this is one of the Falcon sounds. And it usually makes these really harsh metallic sounds, but I think that's really fun. Let me kind of mute the rest. Actually, yeah, I'll just mess up this song. Why not? Yeah, sorry, Raj. I don't want to repeat everything I've already said. But just going over some tools for demo scene stuff. So this is kind of the raw sound. Not that exciting. But it's basically these it's FM synthesis. So you have like a sine wave feeding into another sine wave. So it's like sine of X, where there's some constants and multipliers stuck in there. And that's it. But then the constants in there are controlled by like envelopes. So for example, the inner sine has its own envelope, which will sort of make the amplitude of the sine wave kind of ramp up and ramp down. And then the second sine wave that takes that as input also has the same sort of thing. So this top row here, in particular waveform, ratio coarse, and ratio semi, those are the first, like this section up here represents the first sine wave. So these are sort of the inputs to the actual sine wave to get its like its waveform, and then also its frequency based on the original note, which is why we use ratio here. So coarse is basically semitones, which is kind of ironic because I call that coarse and semi, but yeah, anyway, semi is sort of more fine-grained. And then this sine wave can actually feed back into itself, so that's why there's feedback, and then it can feed forward into the other sine wave. So that's what these different amounts are. Like if I turn this feed forward all the way down, we get a sine wave because that's what the second sine wave is. But then when we feed it with this sine wave, we get something a little more exciting. Ah, yeah, driven. Those are not the most fun languages to make a compiler in. But yeah, so like these envelope parameters, for example, I can turn the sustain up to here. You can kind of see. I mean, this is what me and Hoffman do, is we just sit here, tweak these knobs. Oh, and stuff gets nuts. Yeah. If FPGA ever consider taking the synth to some embedded demo platform, probably not this synth. It's probably way too heavy in terms of processing power. It is not optimized. Well, it's not speed optimized. In fact, it's really not that size optimized either. Like we only really it's small just because we've done it all ourselves, more so than anything else. I hope so, Hardy. Looking forward to seeing your stuff at revision, by the way. The other thing that the synth device has, as I mentioned earlier, is voicing. So there's this unisono parameter which basically determines how many voices there are. So if I go back to just like the raw FM sound, I'll turn that up a little bit. Unisono is actually how many of these whole configurations there are playing at once. So if I turn that down, we get one, and because of the panning, it's actually all the way over to one side. We can bump that up, for example. And now it's playing two of those. And these are, when I turn the panning up here, it actually pans the voices like separately. So if I turn this up, it kind of spreads the panning around for each voice. We get a lot of phasing though when we start getting too high, which sometimes is desirable, sometimes is not. We also control how far the different voices are detuned. There's also like a vibrato. Yeah, so I'm just breaking our song here. F Master, if you can make the FM8 constants public, that would be terrific. I can just show this. Thanks, Driven. I can just show you those constants because they weren't that tricky. It was just kind of hard to find the configuration. But and I didn't dig into any like FM8 code. It's just that I got mine to match theirs with a bunch of round numbers. So that's why I'm pretty sure they're correct. But there's not that much in here that's like that magical. I think like it's the way I think of this synth is like it's, and kind of what I thought about when making it, and also kind of still think about when working on it, is like this is not like the best synth ever. Or like, I don't give a shit about any of that kind of attitude. I don't buy into any of that at all. It's just that like this is a synth that I made to work with my workflow, and it happens to work well with Hoffman as well. And now he's making stuff for himself too, which is really cool. But it's just like, let's just do like bread and butter. What do we actually need to make music here? And then just do what works. Like it's pretty safe, I think, in a lot of ways. But it ends up being the right mix of stuff for us to make really cool things. Bass effect. How much CPU does the music take when playing? Depends. This is a pretty heavy synth, so like it can take up to like 8% CPU depending on the song and depending on what's going on. And there was one intro where we ended up pre-calculating the song because we ran into some denormal issues, which, yeah, all bets are off in terms of speed there. And this could definitely be optimized. There's a couple things that kind of keep us from reducing that right now. Particularly, one of them is that we're not using SSC right now, and I really don't want to get into why, because it has there's a lot of technical details with keeping our executable small. And yeah, I'm not going to get into why, but like we can't use that, which really hurts the synth in terms of speed. And a couple other things. It's also just not been that optimized. Anyway, let me try to find some of these parameters in here. So we're looking at Falcon Voice. So basically we're looking at the code for this configuration here, all this knob stuff here. And depending on these parameters, there's one or more of those, and then all those get mixed and pumped through this knob. So all this stuff here. And oh, there's a value, 13.25. Hold on, let me try to find out where these were. I should also, I don't have FM8 on here right now. I could show you the configuration that we took that though, or that we took that from. But I mean, so the whole thing is like there's these two basically sine waves, although this waveform actually, so FM8 has different bass waveforms all the operators use. In this case, we basically crossfade here from perfect sine to square 135. So we're just adding a couple harmonics that we fade in with this. And then, so that's a lot of what you're seeing. So here you're seeing it just sets up like, it knows it's going to process a bunch of samples. So it just takes in its parameters and just sets up a bunch of like scalars and those kind of things for the different voices, like pre-calculates those for the sample loop. And then we actually go through all the samples. So the oscillator one input, so this is the input to the first operator. It's going to be its phase divided by the sample rate and stuff. And all this stuff gets nice and flattened. And then we feed back into itself. So this is literally just taking its current phase plus its previous value, basically. And then we take sine of that. And then we mix in the other harmonics, depending on the waveform. Times its envelope value times 13.25. And I think, honestly, this 13.25 was one of the magic numbers. Because we put that there, and then we take the oscillator 2's input is basically the same thing it had, although it also adds oscillator 1's output. It's literally just 2 operators, and yeah, I really wish I had FM8 installed so I could actually show you the thing. I could like draw it. So this is purely from memory, and I'll probably get some of this wrong. But it's like, so you have the different like grids. Pretend there's 8 of those, and you have the different operators. It's an operator and an operator, and this one feeds into this one, and this one feeds into itself, and this one feeds into itself, and this one feeds to the output. Like, that's the configuration. And if you make it an FM8, it'll look like this. And that 13.25 is applied, it looks like here and here. So just super straightforward. And yeah, that's basically it. Then the oscillator 2 output, just pump it through a sine, add a couple harmonics depending on the waveform. Yeah, and that is it. And then we just take the master scaler and then we, sum all the outputs. And then update like envelopes and stuff like that. Also apply vibrato, things like that. The voicing as well was also basically modeled after the voicing parameters you get in Massive. I didn't, what was I saying? I didn't try to like isolate the actual like parameter values in that case. I only tried to do it here with the FM stuff, because FM is really unruly if you get like the wrong values, which sometimes you want. So you kind of want it to be, things to kind of explode a bit, but, anyway, yeah, pretty simple. I mean, simple for audio stuff. Like, there's really no magic in the code here. Scissor, we basically have like a hard clipper. Slaughter is one of our bigger devices, and that's the subtractive synth. Here's a really slow oscillator implementation that I need to optimize. Don't want to talk too much about that. But yeah, just basically like figure out all the outputs of each oscillator, add them together, add them through a filter, adjust the filter's frequency with the filter envelope, all that stuff. So I mean, it's kind of straightforward in that sense. So when we're basically ready to pack this, let me yeah, actually I can pull up, I don't know if this is the latest. I can pull up the Elysian tune, although I don't really know my way around that because I didn't work on that track. But I was going to kind of show you what like the process is to actually get this into an executable looks like. There's also a tiny bit more stuff we're doing now because of Rust, but it really only changes some of the top level stuff, and it's not terribly important. In fact, I probably I'll probably go over that later when I talk about some of the other tooling. Creepbot, what about the mixer? So there is like, let me pull up this track and I'll tell you. That's a good question. Okay, so this is the latest. So this is probably the final of this track. I don't know. Look at this MIDI, by the way. And we don't even like quantize this shit. Like, this is just this song is big. Anyway, yeah, so about the mixer. So Ableton's like mixer here is really basic. Like it just has volume and stuff, volume and panning, and then like sends for different send tracks. In this case, we use, like, you can also see it over here, basically volume and panning, and then outputs to the different send tracks. Like that's basically it that you get out of the box. And so we just use that. And in fact, we also disallow automation here. In fact, I just realized I think he's automating one of these, which is not supported in the replayer. That's kind of funny. But then in order to do things like EQ, we don't do that on the mixer. We just have this leveler device, which will give us a 3-band EQ and then low pass and high pass. And that's it. These are just super basic. These are biquad filters, which are not the greatest at all. But I mean, the whole thing with the synth is like, okay, let's just use straightforward stuff. And what you hear is what you get. So you get the workflow and you're able to tweak things really quickly. Then you don't really need perfect synthesis because, like, if you have ears, you can work with it. So it's like you get a comfortable environment to work with something that is not the greatest thing, but should have the tools you need. Seriously, Elysium V3 new final improved. Yeah, that's actually what I was looking for. I was looking for some stupid file name like that because that's what we usually end up with. But in this case, it's just number 12. Anyway, that's all we really do for like the mixer. So in terms of actually mixing these tracks, it's literally just like figure out the panning values for left and right channels, and with the master volume. So we have these multipliers. We multiply the left by the left multiplier and the right by the right multiplier, and we sum all those into other voices. Like it's really basic at the mixer stage, just adding some floats. I think that's really pretty. Yeah, I hope I'm not embarrassing Hoff by all like the track names and stuff, but this is, I mean, if I made the song, they would have just as weird names. Like that's just, you get in the flow and you just do not care about that stuff. And that's kind of the fun part about like using a tool like Ableton is like it looks like a toy. So you just play with stuff. I think that's really important for these kind of tools. If it looks too much like some professional thing, I don't want to touch it. Is at least the case for me. Yeah, copy of Big Ass Pad. Oh, that's great. Yes, F Master, you do hear sidechain. In fact, I believe this master track down here, or this track here, is called probably Fuck a Duck? Fuck a Duck, that's what it's called. And I'm guessing that it's called that because he's ducking these things here. I'm guessing it's sidechain for both the from both the kick and the snare. Yeah, so you hear that sidechain ducking that. Drift, cool. Yeah, man, just come hang out. I guess it'd be the kick and the clap in this case. Maybe it's just the kick. One of the things I do not like about Ableton is the routing when you have to do tracks like this. So I'm not actually sure what's feeding into that. It's here. Yeah, because it uses this first send track, I think. Or is that here? No, okay, here we go. Yeah. Sorry, I was missing these guys that are right above my face. That's okay. So maybe you can't see there's the fucking duck. I don't know if you missed that earlier. At Lizard CRC, there's no limit to the number of instruments. I mean, once we actually pack this, it might be too big, and then we might reduce things. But yeah, there's no limit because there's really no reason to have a limit. There's no no limit on the number of effects you have either. Yeah, we have sends and everything, and that's because that's like the only way you can actually do this stuff with Ableton. But also it makes sense to bus a lot of things, like to bus all the sidechain stuff, or to bus all the kick, or all the drums, or to bus all the basses to like do bus processing. So it's mostly a workflow thing, but I mean it's like the graph in the intro. Every track just has a list of input tracks, like tracks that will feed into it, and so really to support things like sends, like in Ableton, we just have to transform it to that structure. Just say like, okay, well, all the things that we're going to the sends just feed into this track. So like we don't have sends in the replayer data. We just have tracks that accept input from other tracks, if that makes sense. And that covers all the cases here. The rest are just like, oh, how do you look at the Ableton data and then get it into that structure? But then that's actually relatively straightforward, and you kind of just handle it case by case. So Hunter, yeah, there's a 64K limit. I think V2 had some of those limits also because it was doing probably because it was optimized, but also probably because of the it had to do like MIDI routing to get MIDI to all the different instruments, because it's a monolithic VST, and that was one of the things I never liked about those monolithic VSTs, is that you have to do a lot of routing in your DAW to actually get data into there. Whereas something like this, you just make the music, or so it should feel. I mean, the consequence is that then we have to pull that routing data back out, but then we can do that if we understand the project format. The downside of which, of course, is that we're locked to a couple different DAWs with project formats, but that's fine. Given our actual parameters, which are me and Hoffman need to make music, Ableton's just fine. So once we have a song that's basically ready, like this one, let me do some explorer digging. Here. What I basically do, hold on, I just need to fill in some paths here. Actually, this will work. Some other colorful names here. Okay, we want to actually do a different one there. Yeah, there's a little, a couple vocal samples in this track. The sampler, I mean, it really only uses like mono samples, but you can have any sample in there as long as it's under the limit. Like this song is really big because it uses a lot of samples, but also has a lot of big MIDI. But it's fine. I mean, the whole intro is 56K, and I'm not the kind of guy that likes to start size optimizing until we have to, and we just didn't have to. Anyway, what I'm going to show you here, is it in test? Yeah, it's in here. Just to show you, that should do it. So I'm just changing the parameters to this convert the fuck project. So what I do is I run this. So like let's say we just finished this track, right, and we're ready to go. Hoffman sends it to me, or we worked on it, and I'm ready to pack everything up. So I put it in as the first parameter here, and then as the output parameter, I put in basically a header file. So if I run this, we'll get a tiny bit of output, which is basically that devices were skipped. The converter will like skip disabled devices when it's packing everything. It will also skip unrecognized VSTs. So one of the things that we tend to do is put in a bunch of other VSTs that are just like scopes, and the converter will just ignore them, but it helps us kind of visualize what's going on in the music. And then after that song just got generated or just got dumped to this header file here. So we have a device factory here, and packing the device factory with the song data actually allows us to strip devices without having to do any like really crazy conditional compilation in the code itself. We just rely on link time optimization to just strip everything out, which is nice because then we don't have to actually change the code to have that kind of feature. And then there's this binary data, and this binary data is exactly what I mentioned before. Like this is has like all the samples, has all the devices, all that stuff. And then if I run this player test project, it'll play the song. So the whole idea is that we're able to do that really quickly. Also, this, by the way, I don't think it gets compressed here. I just kind of want to see how big that is uncompressed, but it's a couple 100K, I think. Um, 95K. If that's the right one. Yeah, it is. 95 kilobytes uncompressed. For just the audio. Creekpot, I can listen to your stuff all day long. Thanks, man. Do you have this on SoundCloud? So I'm on SoundCloud and Hoffman's on SoundCloud. I believe this one will be on his. Let me pull that up really quick. And so after we get a small executable, that gets, oh, where did it come on? Where's Hoffman? There he is. So this is his SoundCloud. Yeah, you can also go through my website to find mine. But this is Hoffman's, and that'll have the Elysian track on it, plus some other stuff. I usually don't put a lot of my demo scene stuff on SoundCloud, so, which is kind of dumb, because I was trying to be serious with music for a while, which is a mistake. Anyway, what was I saying? I don't remember. Oh yeah. Once we have the executable, I think like Elysian uncompressed was like 220K or something. But all the data is meant to be really compressible, not necessarily small by itself. So once we have that, we put it through a compressor. In that case, we used Crunchy. I did a bunch of work last summer to work on my own packer, which probably isn't going to be ready for revision. So it'll be ready eventually, but right now we're just using Crunchy, and that's fine. But I think I mentioned that on the last emulator stream, that the idea there is like, okay, Crunchy is really good, but it's like 10 years old. And it's not that compression techniques have gotten that much better since then, because they kind of haven't. At least not in terms of like, okay, we can use a lot of time to decompress, but let's get the best ratio possible. But the amount of CPU cycles we get for the same amount of loading time has definitely increased. So I'm kind of trying to play with new things and try to take advantage of that. Yeah, I haven't tried Beer Pecker, but I'll have to try that. Have to give that a shot, unless we do some custom stuff in Crunchy in the meantime, because that's fun. So we'll see. Anyway, I think that was all that I kind of wanted to cover. It may have been a bit scatterbrained, but I just kind of want this to be pretty casual, so I don't really worry about that. If you guys have any more questions, though, I have like 5-10 more minutes before I gotta go. So if you guys are curious about anything, want me to dig into some more of this stuff, fire away. Thanks, Studio-C. Appreciate it. F-Master, do you have a DSP background? So not professionally. I've done a fair bit of DSP in the demo scene stuff, but like I didn't know how to do that stuff and then come into the demo scene. I came into the demo scene and then wanted to do that stuff. So one of those things where I learned enough to do those kind of applications. So design, no problem. Glad you guys are finding this this informative and fun. The next few weeks for this stream, we'll be going over some more of the tools. So I want to go over the visual tools we're using. I want to go over some of the stuff I've been doing for Super Nintendo. I want to go over some of the other some of the demos we've done with this stuff in particular, and go over like techniques that we used in the demos. So not just the tools. And then after revision, I want to do, and maybe a little before revision, I want to just do like, let's sit down and make stuff. So that should be pretty fun. John Hunter, you can do a demo in Python. No worries. Group what's your musical background? So it's, again, I started doing music in the demo scene. I eventually did music like on its own as well. Now I kind of do here and there stuff. Anyway, started in the demo scene, but I guess I've been doing music for a lot of years now. Mostly synth stuff. Played drums for a while. Bass Effect, yeah, we'll release this package soon enough. Won't be before revision though, just because it's pretty orthogonal to our current goal. Yeah, I should put more stuff on my SoundCloud because I have a lot of like demo scene stuff that I don't have on there. And I had a ton of Game Boy stuff too. I do a lot of, or I should say did do a lot of LSDJ stuff, which is really fun. I want to do more of that stuff, so should put some of that up. Lizard CRC, I do have a synth for 4Ks. I released one of those, which is called Sonnet. It was used in our Muon Baryon intro from like 2009. And then after I made a Sonnet 2. Sonnet 2 never went public. Sonnet you can actually find on Poet. I can actually pull that up. But it wasn't, even at the time, it wasn't very good. And then, of course, Forkline came along, which is a better synth. But I would encourage people to try and make their own synths. And just, like, it's really cool to have your own tools. They're fun to make, and I kind of like the diversity in the tools that people use to make demos. If everyone's using the same tools, like, okay, that means they're great tools, but it's like, I don't know. When you make your own synth, it will have character. If you make your own visual tool, your demos will have character. Like, I have yet to hear a snare from Forklang where I didn't go, oh, that's Forklang. For example, like different synths have different kind of character. So make your own, because then we get more stuff on the scene. Even if it's not going to be as good, it's cooler if you made your own. In my opinion. And that's also my hope, like when we release WaveSabre eventually, that people will not just use the out of the box devices. I hope people would make their own. So yeah, I'm not really sure what I think I wrote down a plan for what the streams are going to be in the next few weeks. I'm probably just going to play it by ear. So just tune in every Sunday. Seriously, that's really cool. Really cool you remember that. I haven't talked to that guy in a lot of years, but yeah. Very talented coder. That's funny you remember that. Hardy, yeah, snares in general are hard to make. At least in 64K, we just get away with using samples. But even then, we have to do a lot of post-processing. But yeah. Anyway, I think I'm going to go. Thanks, guys, for hanging out. And thanks for watching. This is going to be a weekly thing. So tune in next week. Also, remember I have, or if you guys haven't seen those, but I do an emulator stream every Thursday as well. And then also I stream some other stuff here and there. mostly the stuff I've been streaming that's not the emulator stream, and then this stream has been I've been learning some speedrunning for Ocarina of Time, so you guys are interested in some of that stuff or just want to hang out, you can bug me on there, but that'll just be pretty random. Anyway, thanks a lot again, guys. Appreciate it, and see you later.